Hello everyone. Today the topic that we are going to study is called internal energy. This is in the chapter Thermodynamics, class 11, Thermodynamics. So we are going to cover internal energy, and we are also going to study about enthalpy. So let us see what is this internal energy, right? Okay. So for example, let us assume that there are gas molecules which are present in a beaker. Okay. So we know that, these gas molecules, they would have certain kinetic energy, right? Kinetic energy, what is kinetic energy? Energy due to motion or energy due to movement. So these molecules are continuously moving. So they would have a certain amount of energy, which we are calling kinetic energy. So they would have translational energy, rotational energy, vibrational energy, right? Okay. And they would also have potential energy. Okay. So potential energy, like there is also a force of attraction between two atoms. There would also be force of repulsion. So potential energy is the energy due to its position. Where are the molecules positioned? So what is this internal energy now? Actually, this internal energy is like a sum total of all the energies, right? It is a sum total of the kinetic energy, the potential energy, and all other energies involved in any system. That is called internal energy, right? So it is the total of not, okay. So here we have kinetic and potential energy. But usually, what is internal energy? It is the sum total of all the energies that are involved in any system. Okay. So here U, internal energy, we represented by U, small u. So here it is equal to the total kinetic energy of all molecules plus the total potential energy of all molecules, right? Okay. Now, what are the properties of the internal energy? Let us understand. So it depends only on the change in the, okay. So basically, it becomes very difficult to us to calculate the internal energy. See, we cannot calculate the total energy of any system. It will become very difficult for us. So we can only calculate the change in the internal energy. Like what is the change in the internal energy? And what is this change caused? It is because of heat or because of work done. There will be some changes that will be caused. So the properties of internal energy, that is, it is dependent only on the change in the temperature of the system. See, if the temperature of the system increases, the kinetic energy would increase, right? So it would also increase the internal energy, right? So we cannot calculate the total internal energy, but always we calculate the difference between the internal energy, right? Okay. Let us understand what is this. Okay. State function. Okay, it is a state function. Now, what is a state function? State function means that it depends on the current state. It does not depend on, how it is achieved. Like, for example, let me give you an example. Like, for example, I say that, this is a hill, a top of a hill, and you are standing here, right? Okay. So you are reaching the top of a hill by climbing the hill, right? So you are doing some work done, right? Okay, so either you can, climb the hill and reach the top, or either you can sit on a helicopter and reach the top. So in both the cases, the work done basically by your body, it depends on the path that you have chosen, right? So if a certain work done, if it depends on the path, we call it the path function. If it does not depend on the path, we call it the state function, right? So like temperature is a state function, right? It does not depend on the path, right? So even if you increase the temperature by 10 degrees Celsius, or you directly increase by 100 degrees Celsius, it's the same thing, right? So internal energy is a state function. It is represented by U. Okay. It is an extensive property. SI unit is joules, right? Basically, all energies, we measure it in joules, right? And total, okay, as I said, that total internal energy, it cannot be measured. Only the change in internal energy is measured. So I hope all of you understood about the internal energy. Let us quickly understand through this image. So here the particles are moving. They have potential energy, kinetic energy, right? Okay. So can we find the absolute value of internal energy? That means the total internal energy? No, we cannot. We can only find the change in internal energy. How? The final internal energy minus the initial, right? So we cannot find out the total internal energy. Okay. Okay. And how can you change the internal energy? You can change it by changing the kinetic energy, by changing the potential energy. Now let us understand one thing, isothermal process. Okay. What happens to the internal energy of an ideal gas in an isothermal process? Okay. What does the isothermal process means? It means that the temperature is constant. See, if the temperature is constant, the kinetic energy is zero and the particles also do not interact. See, potential energy is due to the interaction of the particles. So If the particles do not interact, the potential energy is equal to 0 and the kinetic energy is also equal to 0. So what happens is that, you know, in case of the isothermal process, the internal energy, that is the change in the internal energy, it is always 0, right? Okay, let us move forward. Now we are going to study about enthalpy. As we've already seen what is internal energy, let us move on to enthalpy. So enthalpy is like, total heat content of the system, or, heat measured at a constant pressure. Okay, heat measured at a constant pressure or total heat content of the system. So enthalpy, we use it to do, denote heat, right? As you know, you must have studied about ionization enthalpy in class 11. Ionization enthalpy, that is the amount of energy required to remove the outermost electron, basically energy required, right? So here enthalpy is heat. So what are the properties of enthalpy? Let us study. So enthalpy, obviously it is energy, so the unit is joules. Again, total enthalpy cannot be measured, like just like internal energy, we measure the change in enthalpy. Okay, it is a state function. As I told you, what is a state function, what is a path function, right? It does not depend on the path, it depends on the current situation. Now, okay, let us understand this. What all does enthalpy depend upon? How can you change enthalpy? You can change enthalpy by changing the internal energy. Because if you change the internal energy of the system, so basically, suppose if you are heating a water pot, you increase the temperature, so you are increasing the internal energy by increasing the kinetic energy because particles are moving faster. So there are two ways of increasing enthalpy or the heat energy required, either by increasing internal energy, that is denoted by U, or by doing some work on the system. So for example, if I have a system, if I have like a beaker and I have water, so if I increase the pressure, like basically here the work done on the system, it depends on what? The pressure and the volume, the pressure and volume of the system. So if I change the work done, if I do some work on the system, right, or if the system does some work on the surroundings, right, that is called PV. PV is nothing but work done. So we denote the change. So enthalpy can be changed by changing the internal energy or by, doing some work, which is denoted by PV. So these are the factors by which we can change enthalpy, right? Let us understand. Now there are sign conventions of enthalpy. See, exothermic reactions. Exo means out. That means heat is released. Exothermic, heat is released. So any reactions in which heat is released, like for example, if you had calcium hydroxide, that is slake lime into water, that reaction is exothermic because the beaker becomes very, very hot. Even if you are mixing acid and base, okay? If you mix acid plus base, you get salt and water. If you have done this in your laboratory, if you would touch the beaker appears to be very hot because the energy is released. And whenever the energy is released, we denote it by a negative sign, like delta H, the sign is negative. Okay. If in any case the energy is absorbed by the system, right? We are absorbing the energy from the surroundings. That is called endothermic reaction. And here the system absorbs the heat. I will give you an example. So if I add ammonium chloride into a beaker of water, the beaker appears to be very cold. Now you would think, why is the beaker cold? Because it is absorbing energy from the surroundings. So if it absorbs heat energy from the surroundings, its surroundings, that means, the surroundings of the beaker become very cold. It is cooler than the surroundings. Why it is cooler? Because it is absorbing the energy. So all the energy from the surroundings is absorbed into the beaker, leaving the surroundings very cool. This is called an endothermic reaction, right? An endothermic reaction, delta H is equal to positive. Because you need energy. Energy is being supplied to you, right? That is delta H is positive in case of endothermic reactions. Okay, now let us study the relationship between delta H and delta U. So basically, change in enthalpy, I can write it by delta U plus P delta V plus V delta P. Now, if it is measured at a constant pressure, that means change in pressure is equal to 0. So this entire term becomes 0 because delta P is 0. So V into delta P is 0. So delta H is equal to delta U plus P delta V. Now, okay, you must have heard about PV is equal to nRT, right? Boyle's law. Okay, so here I can change it like this. I can write as delta U is equal to nRT. Now, Ng here, I'm writing Ng, it is the number of difference in the number of moles of the gaseous reactants. Now, what is this Ng? Like suppose PV is equal to NaRT, that this is for this particular system. PVB, that means this is for this gas. If I want to find out the difference of their, moles, right? So how will I find out the moles of A, right? Moles of B minus the moles of A, right? So that is Ng is nothing but difference in the moles of the product minus the reactant, right? So, sorry, this is plus. So now the reaction, now the equation becomes delta H is equal to delta U plus delta NgRT, right? So basically, see, this is what I was telling you. If you subtract PVB minus PVA, right? We always subtract products minus the reactants. That is, NBRT minus NART. So obviously RT would get cancelled, right? So you would get, the difference between the two moles, that is NB minus Na, that is delta NgRT, right? So basically, sorry, it will not get cancelled. If I would take out it as common, so basically it is NB minus Na into RT, right? NB minus Na is what? Delta Ng. So P delta V is equal to delta Ng, right? Okay, into RT. So this is the formula, and now the change in enthalpy is equal to change in internal energy plus delta Ng RT, right? So this is about the relationship between enthalpy and internal energy, right? So let us quickly revise what we have studied today. So we started with the internal energy. Okay, what is internal energy? Internal energy is the total amount of energy in the system. That is the sum of all forms of energy of a system is called internal energy. And internal energy can be changed by changing the kinetic energy and the potential energy, right? And in case of isothermal process, the internal energy is zero. What about enthalpy? Enthalpy is nothing but the total heat content of the system or heat measured at a constant pressure. See, when we are doing the derivation also, we are saying that it is heat measured at a constant pressure, right? Constant pressure. Hence, at constant pressure, this entire term became zero because enthalpy is heat measured at a constant pressure. So delta P is zero. Hence, V into delta P becomes zero, right? Hence, this is the equation for enthalpy. Okay, so I hope all of you understood about internal energy, about enthalpy, and what is the relationship between enthalpy and internal energy. If you want to study in detail, practice more numericals, you can get in touch with me through my Urban Pro profile, right? Thank you so much.